Alright, and excuse me, in this video we are going to be looking at molarity again. So in the last video we had molarity, and you should be saying to yourself that is how many moles of solute. That could be salt, sugar, Kool-Aid. We'll look more closely at some specific examples in class over the next couple of days, per liters of solution. Now, what we're going to take a look at are some problems on page 14 in your homework packet, on the next slide. But before we get to those, you can look back at the old video, one before this, where we're just simply solving for molarity, moles, or liters. But that's not very practical in the lab. So instead, we need to work with grams to moles, or we need to go backwards from moles to grams. And that's going to be the one you're going to do quite a bit of, just because a lot of times you're going to be asked to figure out how many grams of this solute or whatever solid you need to mass out do you have to go over to a balance and actually put on there. So this one right here, the one that my pen is kind of going around a little bit with, this one, that's the one that you're going to use quite a bit. Okay, we'll do a couple of example, at least one example of each one as we go through here. Okay, so basically again, when you have molarity, it's moles per liter, grams to moles, or moles to grams. You're going to have to do both of these. We're going to do a problem involving both. And right now you can turn in your homework packet to page 14, which is going to look something like this. I had put a lot more space in between the individual questions just to give myself some space to write. Alright, and so what we have here, number 6 is asking us what is the molarity of a solution with 6.89 grams of sodium hydroxide and 450 milliliters of total solution. Alright, so I mean, one of the first things you could ask yourself, well, what am I supposed to even do first? Well, remember that molarity from the previous slide is moles divided by liters. And so let's just start there. I mean, if molarity, we can even just do the little triangle thing. Draw a triangle. Not very well. Big capital M for molarity. Moles is going to go up top. Liters is going to go down in the bottom. And in the past, what some students have done is they see they have milliliters and they have that. And we don't know what we do, so let's just plug both of these numbers in, thinking that grams is the same thing as moles, which it's not. Milliliters is the same thing as liters, which it's not. And so you have to convert those to match moles and liters. Let's start the easy one. Let's do 450 milliliters. We know from our notes from the PowerPoint that there's 1,000 milliliters in 1 liter. So converting milliliters to liters, you're just going to divide that by 1,000. So that is going to be 0.45 liters. Alright, so that's the easy one. Now the more tricky one, grams of sodium hydroxide. You have to get 6.89 grams of sodium hydroxide. And so, basically, just start with what you know. You know you have 6.89 grams of sodium hydroxide. Okay? We got to get that to moles. And the reason is you can't calculate molarities using grams. You calculate molarity using moles. And so in order to do that, we saw in our notes, the PowerPoint, that we're just going to divide by the molar mass of sodium hydroxide. Grams will go down here, and 1 mole of sodium hydroxide will go up top. So now we got to figure out the molar mass. So let's go down to our periodic table, and we see that sodium is right here. It's 22.99. So we can go down to our calculator and do clear this out. 22.99. Hydroxide is a hydrogen, an oxygen. This periodic table is from webelements.com. This isn't like what we have in class, so ours in class has oxygen as 16, so I'm actually going to add 16 instead of what you see here from Web Elements, plus 16. And then we have to add in a hydrogen, which is 1.008 plus 1.008. Equals, there's the molar mass of sodium hydroxide, 39.998. For our purposes right now, that's pretty safe to say we can round that to 40. Again, that came from adding a sodium, one oxygen, and one hydrogen together. So the molar mass, we're going to round up to 40. Typically, you're not going to do that, but in this case, we will. All right, and so 6.89 divided by 40, so 6.89 divided by 40 gives us 0.17225. 0.17225 moles. We have our moles. We have our liters. We can now calculate molarity. 0.17225 moles divided by 0.45 liters. And you can pick up your calculator and figure this out. You should get 0.38 molar solution of sodium hydroxide. That's using an old answer key, so that may be off just a tiny bit. We can kind of double check. Let's just do it right here. Divided by 0.45. Yep, 0.38, which is just fine. Alright, so that's calculating molarity if you're given a certain gram amount of a solute and a certain volume. But what if it's the other way around? Okay, what if you have to go backwards? What if you're given molarity in liters and you have to figure out how much you have to go over to the balance and actually put there? So now what we're going to do is we're going to look at number 9, if I can find it here. Kind of unzoom. Number 9. All the way down at the bottom of the page. Okay, we got unzoom, sorry. There we go. Number 9. Describe how you would make 2 liters of a 2 molar solution of KCl, potassium chloride. That is not a K, C, and an I. Another mistake some students make. Again, start with what you know. We know, start with a triangle, means substitute in the numbers that you have, if you can. If the units match, substitute them in. We know molarity, and we know liters. Alright, very simple math. 2.0 molar solution times 2.0 liters is going to give you 4 moles. That's the only unit that doesn't cancel out. So now, all you have to do is it's asking you, how do you make this? And I would reword this question. This was up for discussion in class. How would you make this solution? Well, you got to figure out how many grams of KCl that you need. Alright? So we're going to go 4 moles. We need 4 moles of potassium chloride. Alright? We got to get that to grams, because that's what we're going to go and put on the balance. Let's go to our periodic table. We need a potassium, which is 39.098. Alright? 39.098 plus chlorine, which is right here, 35.45, 35.45, and that is 74.55. We'll just run that to 74.55. grams for 1 mole. And as I wrote that, you may wonder, why is he putting that up top? On the previous problem, he put the mass in the bottom. Yeah, because I was trying to cancel out grams. I'm not trying to cancel out grams. I don't want moles anymore. I want to get rid of moles. Only way to do that is to multiply by the molar mass. And 74.55 multiplied by 4 is 298.192. About 298 grams. You have to go and put over on the balance. Now that makes sense. If 1 mole of potassium chloride weighs about 75 grams, and you need 4 moles of it, you need 4 times that. So this number does make sense. If your number goes down, you should be thinking, okay, if 1 mole weighs this and I get a decimal point and I needed 4 moles, something went wrong. All right, so those are 2 problems in solving for grams or solving for molarity from a gram amount. Okay, rewind back if you need to hear anything again. Stop in if you have any questions, and I will be very happy to help you out if you need some more one-on-one help.